So first of all, angles of elevation and angles of depression. So for both of these, you need to start with a horizontal line. An angle of elevation is the angle coming up from a horizontal line, and the angle of depression is the angle going down. So it's always from that horizontal, up for elevation, down for depression. That means when you want to draw a diagram, you get questions like this, where you've got a person standing on top of a building, and it says the angle of depression, maybe it's 30 degrees. Okay, so can you not yell out, please? The angle of depression is always from that horizontal line. So if I said 30 degrees, it means that that angle in there is 30 degrees, not the one down here. So often people try to put that angle going down to the building. You all right there, Max? Now, once you've got the angle of depression in the right place, you always use alternate angles to move it down into your triangle, and it will become the angle down here. So you put 30 degrees down there. Do you have to go and get a drink?
Max.
Yeah,
Max.
leave.
Max, cover your nose, cover your ears.
Lachlan, that's your one warning. Zip. Enough silly interruptions. On the next page, please. Example number 1. A tower is built on flat land. The angle of elevation of the tower from a point 25 metres away is 27 degrees and 18 minutes. Find the height of the tower to the nearest metre. The most important thing in a word question for trigonometry is getting your diagram right. Often the trigonometry part is not the complicated part, it is getting the diagram right to begin with. So, over on the left here, I'm going to draw my diagram. I have a tower, which is going to be the line, there's my tower, and here is the flat land. The tower is built on flat land, and the angle of elevation of the tower is 27 degrees and 18, let me write that again, 27 degrees, 18 minutes. That's the angle of elevation from the horizontal going up to the top of the tower. This would need to be a right angle. Okay, buildings are built at right angles to the ground. The tower is 25 metres from the person. So that's 25 metres going there. And we're asked to find the height of the tower, which I'm going to call H. And it says to the nearest metre. Please look out for tips in the question as to where to round it. So these are all SOHCAHTOA questions. So you can write that at the top here. SOHCAHTOA. I have the opposite and the adjacent side, so I'll be using tan. Tan theta equals opposite over adjacent is the formula. Subbing into that, I have tan 27 degrees 18 minutes equals, the opposite is H and the hypotenuse is 25. Then I just want to times the 25 over to the other side, so H is by itself. So usually you put the 25 in front of the tan 27 degrees 18 minutes. You don't have to if you put the tan first and then times by 25. It just means on your calculator that you have to make sure you close that bracket for your angle first. Otherwise, it will give you the wrong answer. So that works out to be 13 metres rounded to the nearest metre like I was asked to do. Okay? All right, question 2. From a cliff 80 metres high, the angle of depression of a boat out at sea is 15 degrees and 30 minutes. Sometimes you don't even need to read the whole question to start putting information on your diagram. Reading it in chunks makes it easier. So here is my cliff. There's someone up here on the top of the cliff, and the angle of depression, which means from the horizontal, that angle in there is 15 degrees 30 minutes. Obviously, my diagram is not to scale, and it's not expected to be to scale. Okay, straight away, I use the alternate angles to put that into my triangle. Okay, the next part of the question says, well, actually, the cliff was 80 meters high, so I need that on there as well. So there it is. My cliff, 80 meters high, has an angle of depression of 15 degrees and 30 minutes. How far is the boat from the base of the cliff? So I'm trying to find that distance across the bottom. So again, we're going to be using SOHCAHTOA. This time I have got the opposite side and the adjacent side. So I'll be using tan again. Tan theta equals opposite over adjacent. Substituting in, my theta is 15 degrees 30 minutes. The opposite is 80. And the adjacent is the x. When the x is on the bottom, remember to get that x by itself, it does a switch with the tan 15 degrees 30 minutes. So x is over here by itself. 80 is on the top, and the tan 15 degrees 30 minutes goes to the bottom. Typing that in your calculator, has anyone done it? 288 point. Now this one didn't actually tell us where to round. Let's just do one decimal place. 288.5 meters. Okay, everything okay so far?
Yeah.
Great. Question 3. From a rescue helicopter 800 meters above the ocean, the angles of depression of 2 shipwreck survivors are 50 degrees to survivor 1 and 30 degrees to survivor 2. Part A, draw a labelled diagram which represents the situation. Now I'm going to say straight up, this is probably not the best question because there's actually 2 different diagrams you could draw for this, which will give you 2 different answers. So they would need to give you a little bit more information to make sure you've got the right diagram. Option number 1 for the diagram is, here is my helicopter up here in the sky. And that would be my first survivor down here in the water. Okay, now that one was an angle of depression of 50 degrees. So if I draw my horizontal line across here, that angle around to there is going to be 50 degrees, which I would straight away put into here, 50 degrees. Okay, the second survivor is at an angle of depression of 30 degrees, which means not quite as steep an angle there. That angle there is 30, which means that one there would be the 30 degrees when I move it into the triangle. I am told that the helicopter is 800 meters above the ocean. Okay, so that is one possible diagram. Has anyone thought of the second option? Liam? Yeah. If the helicopter was actually in the middle of the 2 survivors, and you've got 1 survivor on either side down here. So you'd put the 800 meters there, survivor 1 on this side. I'm going to make this my 30 degree angle of depression, which means 30 degrees in there. And the other one, on the other side, a 50 degrees, which means 50 degrees in there. Okay, so this is why I was telling you at the beginning this is not the best question, because that is a very different result to what we're trying to find. So I'm going to choose option number 1 as my diagram. If this did happen to show up on a test, as long as you have drawn your diagram that makes sense, I would have to accept either answer, because it could be drawn either way. Okay, so using the first diagram, we want to calculate how far apart the 2 survivors are. So that is that length in there that I'm going to call x. Now to find that, I'm going to have to use the smaller right angle triangle with the 50 degrees in it to find this length here. Let's call that A. And I'm also going to have to use the big outside triangle to find that total length there, which I will call B. And obviously, if I subtract those two measurements, I'll find the part that I want. All right, so let's do that. So let's find A first of all. I've got the 800 across, which is going to be the opposite, and the A is the adjacent side, so we're using tan again. So tan of 50 degrees is going to be equal to 800 over A. The A is on the bottom, so to get A by itself, I do a switch. With the tan 50, it'll be 800 over tan 50. And that equals 671.3 meters. Now using the big outside right angle triangle with the 30 degrees in it, you know what I mean when I say that? This big outside triangle around here. Very messy that I'm drawing over the top of it. So the opposite is going to be the 800 again, and the B will be the adjacent. We're using tan again. Tan of 30 degrees this time is going to be 800 over B. To get the B by itself, we switch places, the B and the tan 30. And that equals 1385.6 meters. Okay, so using my diagram, if I want to find the X, the distance between my two survivors, I would subtract the 1385.6 minus 671.3. So let's write that down. Therefore, the distance between the survivors equals okay. So that is elevations and depression types of questions. We have another type of question that we want to do today. I'll just give you another second. A few people are still writing that down. All right, on the next page, we also want to talk about bearings. So bearings measure the direction of one object from another. There are two systems that we use to describe bearings. The first one is true bearings. True bearings always start from the north and they're measured in a clockwise direction. And you will see them written with a capital T there on the end. So a bearing of 150 degrees T indicates that it is a true bearing. The other type of bearing that you need to be familiar with is a compass bearing. They're the type of ones where you either start with the north or the south pole, depending on which one is closer. And you'd have something like north 30 degrees west, or north 70 degrees east, or south 20 degrees west. You know, those kind of ones, they're your compass bearings. So most of the questions that we do will be focused on true bearings. However, there are a couple that do use the compass bearings, and one of the ones I'm going to do in here today has a compass bearing in it. So first of all, we want to practice drawing the true bearings. So question 4 there says, sketch the diagram when A is on a bearing of 320 degrees from B. So we draw a little compass. The only thing that you really should show in terms of north, south, east, west is the north. You usually put the N up the top there to indicate that one direction is north. 320 degrees, remember it starts from that north and you want to go clockwise around 320 degrees. Now you don't need to write this on there, but remember that this is 90, 180, and 270. So I'm doing those in orange because you wouldn't normally write those on there for every question. So that means that 320 degrees would be slightly past that 270. It would be somewhere in this vicinity. Okay, it's an approximation. It doesn't have to be accurate. You're not getting your compasses out to measure it, but you draw something in the approximately the right place. You should put a little arc in there, so a little arrow coming around like that, and label 320 degrees on it. Now, we were also given some letters to use. It said sketch a diagram where A is on a bearing of 320 degrees from B. That means that B is the starting point, which is at the center of your compass, and A is the end of that line because it's like we're heading to A from B. Okay, so put those labels on there, please. Okay, so that's how you draw a true bearing. Let's try again for question 5. X is on a bearing of 50 degrees. So you notice the 0 at the front because true bearings should always have 3 digits. So any 2-digit measurement, they'll always put a 0 in front. So X is on a bearing of 50 degrees from Y. Sketch this diagram. So again, let's draw our little compass with our N for north showing on the top there. So 50 degrees, remembering that my 90 degrees is here, it's going to be in that first quadrant in about approximately that direction. So from the north, it is a 50-degree arc around to there. Now, the letters that we're told, it said X is on a bearing of 50 degrees from Y. That means Y is the center of my compass, that's where I'm at, and X is out here where I'm trying to go. X is on a bearing of 50 degrees from the Y. Yeah? Be careful with the way it's worded because you need to know which letters to put where. Question 6. A tree is on a bearing of 265 degrees from a house. What is the bearing of the house from the tree? Okay, so first of all, I'm going to need 2 little compasses here. My first one, I'm starting at the house. So I'm going to put a H in the center of this compass. My N up here for north. From my house, the tree is on a bearing of 265. Now, 265 is very close to 270. Remember, this one here is my 270 line. It's going to be just slightly below that. So down there. I'm going to make that a little bit longer. So round, draw the arc in. That is 265 degrees. So I'm at the house, I'm looking at the tree on a bearing of 265 degrees. So over here is my tree. Now I need to draw a second compass here at the T for tree because the question is asking what is the bearing of the house from the tree. If I now stand at the house, if I'm over here at my second little compass, what is the bearing going back towards the house? So I need to know from this north, I need to know what that angle is around there, the degrees from the north to that bearing line. Now we need to use our geometry skills. The only number that I've been given in the question is that 265. I know that this tiny little angle in here needs to be 5 degrees. Maybe I need to write that. Oh, whoops, now I've drawn my line. I'll draw an arrow in there because it's too squashed. That little angle in there is 5 degrees, okay, to get to that 270. All compasses create parallel lines, okay? The north-south line on both those compasses would be parallel, and the east-west lines are horizontal. They're going to be parallel, okay? So I could draw some alternate angles on here. There is a Z shape. So that little angle in there must also be 5 degrees because of alternate angles. The angle that I'm after is going to be 90 minus that 5 degree to get the angle at the top. So over here, I'm going to write my bearing is going to be equal to 90 minus the 5 degrees, which is 85 degrees. Because I want this as a true bearing, I'm going to put a 0 in front of it to give it 3 digits, and we put a T at the end, which also indicates a true bearing. Not all questions have that T, like even that question there didn't have a T on it, but it is a good practice to get into. Okay, question 7. A plane flies at 600 kilometers per hour and flies from A to B in the direction on a bearing of north 30 degrees east. So that's a compass bearing, not a true bearing. It flies in that direction for 20 minutes. Then the plane flies due east for 15 minutes to point C. Find how far north and east of A the point B is. Don't write too big in this section, okay? There's a bit of stuff that's going to go in here. So first of all, that question is asking me, it says how far north? It's asking me for a distance. I haven't been given any distances in that question. I've been given speeds and I've been given time. So remember your little diagram we use it a lot in science, but also a bit in math. Speed is equal to distance over time. I need to draw that bigger. Sorry, you can't see that very well. So the first thing I'm going to do is work out the distances that plane had travelled. So there was 2 sections. There was a 20-minute section and there was a 15-minute. I'm going to start with the 20-minute one. When t is equal to 20, the distance is going to be equal to the speed times the time. That's what that triangle says, speed times time, right? The speed of that plane is always 600 kilometers an hour. Here in the question, there's the speed. The time is for 20 minutes, but be careful. 600 kilometers per hour and 20 minutes, what's the problem? Different units. I can't have a speed which has a unit in hours and my time in minutes. So 20 minutes, I could write that as 20 over 60. Just divide it by 60 to put it into hours. It's much easier to change a time than it is to change the units in speed. Okay? So timesing that together, that is a distance of 200 kilometers. Okay, now I want to do the same thing for the 15-minute section. So the distance for that one is going to be 600, because this plane speed is always 600, times by 15 over 60, which is a distance of 150 kilometers. So now that we have distances, we can draw this diagram. So I'm going to do that underneath. A plane flies at 600 kilometers an hour. Don't need that part anymore. The bearing was the part that we need. It flies off at north 30 degrees east. So draw a compass. There's my north. North 30 degrees means from that north, I want to go 30 degrees to the right, because east, remember, never eat soggy Weet-Bix. That's how you do your north, south, east, west. Good, yeah. So everyone knows east is on this side. Do you do that? Never eat soggy Weet-Bix? Oh, PTSD. Soggy watermelons. Yeah, that's bad too. Okay.
Watermelon is wet.
Anyway, or the crucifix, never eat soggy wheat. Anyway. Okay, so back to it. North 30 degrees, so there's my 30 degrees towards the east. And that is going to be, I'm going to make this a bit bigger because I don't want my diagram too squished here. That is for 200 kilometers, because that's what we worked out. That 20 minutes was a distance of 200 kilometers. Now, once it's done that 200 kilometers, it says then the plane flies due east, which is heading to the right, due east for the 150 kilometers. So that is heading this direction, perfectly east for 150 kilometers. All right, I'm trying to find how far north and east we are. Let's join that up. Join that up across there. That is obviously not a right angle triangle. But don't worry, we're only using right angle triangles yet. I do need some letters on there. I haven't put those on there yet. So let's go back and do that. A plane flies from A, so this is the A, to B, so that's the B, on a direction of north 30 degrees east for 20 minutes. And then it flies to C for the 150 kilometers. So just getting those letters on there. So finding how far north the point is. Rather than use that green triangle that I've drawn there, it's actually easier to draw a triangle coming across here, which makes a right angle. We know the angle in there is 30 degrees, and we know the hypotenuse is 200. So if I want to know how far north it's gone, I'm just trying to find that length of the triangle there that I'm calling X. So that would be the adjacent side. So knowing the adjacent and the hypotenuse, I would use cos. So over here, I'm going to write to find the north. So this is to find the north distance. I'm going to go cos of 30 equals adjacent is X and hypotenuse is 200. So that's cos equals adjacent over hypotenuse. Is everyone okay with that? I've subbed straight in. Then to get the X by itself, times the 200 across to the other side. So 200 times by cos 30. And that equals, yes. Okay, rounded to 1 decimal place. Now we want to find the east. How far east have they gone? Now we can use our same orange triangle over here, I'm going to call that Y, to find that little bit there. Okay, that's not the whole distance, but that's the start. So using my orange triangle, from the 30, the Y is the opposite and the 200 is the hypotenuse. So that will be using sine. Sine 30 equals opposite is Y and the hypotenuse is 200. Times the 200 across. So 200 times by sine 30, which equals 100 kilometers. And that's it. No, because it only said from A to B. We don't have to do the C part yet. We don't have to do that yet. We do have to do the bearing from C, which is the next part. Ready to go for part C? Can I move that screen? Okay, so part B here says find the true bearing of C from A correct to the nearest degree. So that is, if I just draw one triangle to represent that, here is my compass. I'm going to have my one distance. Actually, I want that to be a bit flatter. I'm at A at the center of that compass, and I want the bearing to C. So I'm going to be trying to find that angle in there, because that's the bearing from the north going around to the line going out to C. Now, we have just worked out a bunch of things that are going to help us. We know the distance north. We know this distance here is 173.2 kilometers. We found out Y up here was 100 kilometers. So that total distance there would be 250 all the way out to C. So that's going to go here. So to find the theta, I have got the opposite and the adjacent. I'll be using tan. Tan theta equals, my opposite is 250 and my adjacent is 173.2. To get the theta, you need to inverse tan. We haven't done one of these yet today. So you inverse tan 250 over 173.2. And it says to the nearest degree. Did anyone do it? 55. Well, to the nearest degree, so I'm just going to stop at 55. Okay, so that's the angle. Let's just make sure we write it as a bearing. Therefore, the true bearing of C from A is 0.55 degrees T. Okay, 3 digits with the T on the end for the true bearing. Easy, right? No worries. We can see the value of a very accurate, neat diagram. Okay, you wouldn't be able to do that question without a diagram where you can read things off. So you need to work on 6B.